Hello everybody and welcome back to Element of Code. This time we'll be going through problems for day 22. And I have already looked into the problem, but I'm not in detail, so I'll be kind of figuring out things as I go. So today's problem deals with sand slabs, and we are given a set of bricks that are piled up, and we need to figure out which can be disintegrated safely so that none of the others fall down. The positions, like the bricks, are defined by given two sets of coordinates, x, y, z, and so that's the first point, like one corner of that brick, and another one is given by another set of x, y, z coordinates. So these bricks have integer positions above the ground, and if the coordinates are the same for the end and beginning, that means it's a cube, so it has no like 1, 1, 1 size. Okay, so we can check here. So if the difference of, like, the sum of differences of coordinates is 1, it means that the brick is kind of a 2 cube volume sized, and you can see how it extends in the x direction and y direction. Ground is at z equals 0, so and it's perfectly flat. So that's the lowest z value that a brick can have. Okay, so the lowest value is 1 because the bricks, we are given the top left kind of coordinate, so it means these are on the ground because it's one is has the y z coordinate at 1 and extends up to 5. Okay, so what we are given is the bricks coordinates in the motion, so they can be still in the air. They never rotate, so they just fall down continuously. And what we need to figure out is first how they fall down, how they stabilize, and once they stabilized, then we need to figure out which can be disintegrated, which means which can be removed without the other ones falling down at all. So those which have that specific feature, they can be disintegrated, and we have to calculate how many are there. So we first need to make them fall down safely without them and moving anymore, and then we need to figure out which are can be safely disintegrated. So what I will do is I will take the sample input first, put it here, and make it a startup project, and let's try this. So input, I'll read the input. Let's see we can read the lines, and each line is a brick. So I will have some kind of, let's create some kind of brick class that will be represented by a set of, it's going to be a record maybe, and that one will have a point x1 x, oh no, not like that, that's not what I want. I want x z y1 z1, and then point x2, point x2, point y2, and point z2. So this will give us the coordinates. I will just make it capital so it's nicer for use. And this can be a record because we will never change or actually we'll be changing those coordinates. So actually would be better to have these as a... I can keep it a record, but I'll want to update it. Well, let's do a class instead. So let's turn this into a class, and I will create a property prop int x1, y1, z1, and public int x2, y2, and oh, come on, compile it. Yes, z2. So this are our properties that we'll need. And what I want also is to have a constructor which will pass in all those properties. So int x1, or actually we can we generate this? All right, we don't have that feature built into Visual Studio. Maybe generate constructor, generate constructor with all the properties. Yes, that's the one I need. So that's this, and we will have probably some helpful methods there. But for now, it's like this. So what I will do is for each line in input, I will do parts line split by new, and it's gonna be, what are the comma and tilde, and exactly. So we'll do x1, y1, z1, x2, y2, z2, and then generate a break out of that. So that's all good. And then we'll have those breaks in some list. So we have the list there, and now what we want is to make them fall down. Ideally, like make them fall down to the ground. So at the point where we take the snapshot, they are somewhere in the air, and we need to figure out how far can each of them go. And one crucial thing that we need to notice is that if we sort them by the minimum of the z coordinate, we will be able to quite easily check if for each of those breaks we can check if it will hit something only if it can hit only only the breaks which have lower or not equal, I think, lower z coordinate than that break itself, which is good because it will simplify the checks. So I can do like int min z, something like min z coordinate, and I can do, I can sort them by the min z coordinate, and then I can go through that. So for sorted breaks, or actually, yes, well, forever. It's probably fine just to create a new list for now. So now what I want, or actually I will go with a for loop. I'll call it current break. And I will go with break check ID, and I will make that less than current break ID. So basically I will be going through the list and figure out how far can that break fall. So So this is the current min z, and I will be checking if there is a break that prevents it from falling down further. So actually we can mark this as 1, because ideally it can fall down to the coordinate of 1. But if there is something that prevents it, then we will have to pile it out on top of it. So we will we'll need a way to figure out if a brick intersects another one, and that's something that apparently this could be doing. Let's see. Well, it's not completely correct, because we have width and height and x, y, so it's basically +1. All of the time, like width and height is the difference +1, because if the coordinates are the same, then it's still 1, 1, 1 size. So let's do it like this and like this, and we can check if these two rectangles intersect each other. So and it's intersecting the brick in terms of the shape of the horizontal layer. So this will tell us if the horizontal shape of the brick intersects with the horizontal shape of another brick, which means that that brick will prevent it from going further. So we'll have also a max z. And this is very useful because we can use the rectangle implementation from system drawing, which already has intersect implementation, which is annoying to figure out. So it's a good thing that this is there, makes it easier. And because everything is a break, so there's no weird shapes involved, which makes the calculation much easier as well. So if break to check and current break. So if a break to check intersects current break, then we need to take the max of the z coordinate of that break +1 and the current min z. And we need to, when we're done with this, we need to move that break in the z coordinate accordingly. So update z will be current break min z minus delta z. So this is the difference by which we move the break. So this is the new coordinate. So we now update the break by moving z1 and it's z2, and I think that should be correct, hopefully. Can we, is there a... We can probably check it against this example here. So So now now after this, hopefully, all of the bricks should have fallen down in a location. Yeah, hopefully, yeah, that should be the case. So now they are correctly sorted. So now that they are, we should be able to see we need to figure out which bricks are supporting another bricks and which to see if removing a brick will cause some of them to fall. But let's first verify if we did the sorting, the falling down correctly. So I will do console right line like for plus, and I will just output the individual bricks. And the brick, I will need a toString here. That's going to be helpful. Exactly. So now let's run this. So the updated coordinates, okay. So for example, let's see. So E should be on G, okay. Need to figure out how to view this. Okay, E, F, G. 1, 2, and G. For example, G is 5, 6. Yes, that seems so. F is 4. This one is 3, and this one is 3. B, C is 2, and A. Okay, like it seems okay. So we'll see how that works. Further. So I will have to go through all the bricks and for each of them I will check what supports them. So basically I create a dictionary of bricks, and now I'll have to resort those. Because it's possible that now they have fallen, but some which were previously lower are no longer, like some that were higher have fallen to lower location, while others were blocked by something. So we need to resort again. And I will be going through them again. And we'll check if they overlap. So, oh, okay, we can probably take that suggestion. So if it intersects, we will say that that break supports the break. Okay, I could actually create a support breaks, add break, and with a new list, and then we can add it there. So we say that this break we checked is supporting our current break. So we kind of list all of those which are supported by others, and then what we can do is go through breaks again and see name it. So I'll start with 0A, and the name will be ++. And this way I can actually output what the findings. So breaks. Yeah, something like this probably. So we check that the break is supported by we actually need, let's store the names maybe, because they are displaying as names. So for now we can also do that. So just for debugging purposes. But we will probably ditch that afterwards, because for more properties that's not going to work. Well, we can use numbers instead, probably. So name ++, and then we can do break name is supported by support breaks. Select B name, and we can do without this now. So let's see what happens if we do this. Okay. B is supported. We have the other way around, maybe, because we need to know what supports what. Right. So maybe like this is better. And let's do a hash set, so it's just cleaner. So now maybe, so supported by, so break is supported by, supports, break to check supports the current break. That makes sense. Although it can be null, so let's now initialize it first. So for each break, and just initialize it for now. So just like this, I think it's gonna be fine. Except for supports. So let's see. Okay. I'm trying to add it again. Maybe now. So A is supporting and actually that is not correct because we need to make sure here it's not the same thing because it needs to intersect and it has to be on the same z coordinate. So brick to check max z must be equal +1 must be equal to current brick min z. I think that should be it. And let's see. So it's supporting B and C, D and E, D and E, F, F, G, and supporting any bricks. So that makes sense. Now the ones, okay, so we have this seems to be working now. So I will ditch the names maybe, or I will do instead ID 0, just use IDs. So instead of the name, we'll do int ID, and ID. Right, so we have this done. So now just fix this. And we can make it show the text as well, but whatever. So to check what can be disintegrated, we can go through the bricks and we can check if current break. We can check if the bricks that are supported by current break have greater count than 1, because if they do, we can safely disintegrate it. So if the bricks supported by the current brick have more than 1, it's safe to disintegrate. Like no, rather each supported brick. So for each of those that are supported by this brick, safe, true. So we will be checking if is safe, false. So basically we'll be checking if it's supported by something else, and if not, we will be setting as not safe, and then we break and safe to disintegrate, and we okay, maybe more readable is safe to disintegrate plus plus. So that's maybe better. So now if we run this, we should, oh right, I wasn't outputting this, but right line, safe to disintegrate. So now we should see number 5 here, which means that 5 of them can be safely disintegrated. So let's try this with the bigger input. We'll see what happens. So I have the output on the top. So 760 is my answer. It's too high. Okay, so that's definitely too high then. Okay. Let's see. Okay, let's check if this happens, because that would be a weird thing, but this doesn't happen. Okay, so. All right. Okay. So if what could be the problem here? We can definitely disintegrate those which have zero, which are supporting zero bricks. So that is fine. Thinking if this could help. So skip this, but still 716 now. Change there. So that logic is sound. Brick is support, so the current brick is supported by the brick that we're checking, and brick that we're checking is supporting the current brick. So that seems okay. No clues on what can be wrong right now. And am I doing it the other way around? Like, So it's supported. So current brick is supported by the brick to check. So it means rather we need this supports supported by. So this way around, right? 451, let's see. Okay. So I was flipping the logic. So the meaning, the name of this dictionary, these dictionaries is apparently not that great, because it's this one says how many are supported. What is this given brick supported by? And this gives the information what given brick supports. So I had it just the opposite way. So I had, instead of supported by, supports, and that meant that I was checking the opposite thing basically. Okay, so that was a little bit weird, but anyway, glad that it's cleaned up. So we can safely proceed to the second part. So now we need, instead of disintegrating by one at a time, we need a chain reaction. So instead of for each brick, we need to determine how many other bricks will fall if that brick were disintegrated. It would cause 6 to fall. This would cause only 1 brick to fall. So for each brick, we're checking how many other bricks will fall if it is disintegrated. Okay, so what we need is to calculate something like so basically the ones that cannot be disintegrated will be the ones for which we will be counting the number of those which will be falling. But we'll check how many are those. So if it's not safe to disintegrate, we're counting how many. So for each let's see, I still need to refresh this. So supported by the current brick. So for all those which this brick supports, we'll be checking we'll be counting. We can count 0. Yeah, so if its count is 0, we will add it to the fall down count, and if it's not safe, we will do disintegration total plus equals fall down count and just output this. Can we check this on the simple example first? Take it, put it here, and let's see. should be 7. It's 3. That's not correct. Because we need to, because those falling down will cause other ones to fall down as well. So we need to figure out yes, right. So if this is not enough, we need to figure out okay, so we need to figure out the transitive number instead. So down, set brick. So for each of these bricks that are not safe, we'll go through we'll have a method maybe. Right, we need to be able to check it as we go. Well, actually, yeah, we can do it recursively, I guess. So if that supported brick contains, so we fall down all of those supported ones. I would say we could do something like a queue of those. Like this one. Queue. We add we will add the ones that are ports break. So while that fall queue is not 0, ETQ that break. Yeah, so we ETQ the next break that will fall down. Mark it as fall down break, and for each of those that this break supports, so we mark it if all the bricks that this brick is supported by would fall down, then this one will also fall down. Yes, that makes sense to me at least. We'll see if that really is correct and if it captures everything, but it doesn't apparently. So I have to probably adjust this a little bit more because like initially. Yeah, I need to add current brick as well. And that will mean that the result will be bigger by 1. So I need to decrease it. And that is correct for the simple sample. But the question is if it's going to be correct in the big sample as well. So let's see. Let's run it. And the number, okay, that is probably even more. Well, it's fine. It can be more than the number of bricks. So let's see. And that is correct. Okay. So that's pretty good. So the trick was to mark all those which will fall down as a result of a brick being removed, and then check if all the ones that support this brick will fall down and so on. So this was kind of a queue-based solution. I'm not sure if there's probably some nicer way to do it. Like the thing is that if I remove one brick and another one affects another brick, I'm thinking that there's a nicer way to do it, but like technically every time I add a brick into that fall down list, I should check if that one also supports something that can fall down. So technically maybe it could be simplified. If I do check brick and I do put so if support so for each, so if the given brick fell down, I need to check all its supported brick in supports brick. I need to check everything it supports, and if not would fall down contain supported brick, if it doesn't contain it yet, and supported by supported break all the would fall down contains B, then this one will fall down as well. So would fall down, add supported break, and check fall down for that break as well. And I think that will be the equivalent solution. If I run, actually call that method, of course. So fall down, current break. That should be the equivalent solution to what I've just did. Yes, it's the same result. So apparently there's two ways to do it, and this recursive one maybe feels less convoluted. I don't know. But anyways, the good thing is that we've solved day 22, so there is just 3 more days to go. So closing it, even though not really fast, but it's happening. So I will see you in the next video solving day 23. And actually I will do one more video, of course, where ChatGPT will try to solve this problem day 22. We'll see if it's able to figure out this falling down of sand slabs. But until next time, hope your code compiles, and I will see you in the next video. Please subscribe or give it a like if you liked what you saw, because I will be publishing more videos, so it's always nice to have you here. So see you next time, and bye bye.